Hey everybody, how you doing? Mr. Elliott here, just checking the volume. I think it looks good. Let's get to it, shall we? You probably just watched the Michigan basketball game, and hopefully Michigan came out victorious. And now we got to do some math. So this is one of those lessons that if you're watching this on Thursday night, before I introduce the topic, this might not make any sense. And if that is, no worries, just get all this information copied down now, and then if you need to watch the video tomorrow in class, I get it. So let's do this first problem. We're evaluating the sigma notation, and whenever I see a sigma notation problem, the big key word I think of is sigma means sum. It means that you need to add it up. And what's nice about sigma notation is that not only does it give you a starting point with n equals 1, it gives you an ending point with n equals 4. So first you plug in 1. 2 times 1 plus 3. Then you plug in 2. 2 times 2 plus 3. Then you plug in 3. 2 times 3 plus 3. Then you plug in 4. 2 times 4 plus 3. And then you're done because you started at 1 and you plugged that one in first, and then you kept going until you had plugged in 4, and then you are done. And let's see, this worked out to be 5 plus 7 plus 9 plus 11, and those four numbers add up to, let's see, those two add up to 20, those two add up to 12, 12 plus 20, 32. Very nice. Okay, so that's what's nice about sigma notation is it does give you a starting and an ending point, and because sigma means sum, you are adding all of these terms together to get to your final answer. Number 2, let's do one more of these. Sigma n equals 2 up to 6 of 3n squared. So typically we start a series with either an n equals 0 or an n equals 1. But truthfully, it could start anywhere. And in this case, it starts at 2 and it ends at 6. So first we plug in 2. Oops, I wrote that wrong. 3 times 2 squared. Then plus 3 times 3 squared. Plus 3 times 4 squared. Plus 3 times 5 squared. Plus 3 times 6 squared. You start working it out. Let's see, 2 squared, that's 4. 4 times 3, that's 12. Plus 3 squared, that's 9. 9 times 3, 27. Plus 16 times 3 is 48. Plus 25 times 3, 75. Plus 6 squared, 36 times 3, 108. And then all this adds up to, I could do that in my head if I wanted to, but it's just going to be a smidgen lazy right now. Let's see. Oops, start over. 12 plus 27 plus 48 plus 75 plus 108 equals 270. And then because I was just using this cheap 4-function calculator, I'm going to run through it twice just to make sure I did it right. Ooh, but I'm going to do it fun-wise. Instead of adding all these up to see if they get to 270, I'm going to subtract all these numbers and see if I get 108. So 270 minus 75 minus 48 minus 27 minus 12. And the only one I haven't subtracted is 108, so when I hit equals, 108. I must have done this right. So those are sigma notation problems when you are given the sigma and you have to write, you got to figure out what that sigma notation is equal to. These sets of problems are backwards problems where you want to write an equation for it. And it should be a sigma notation equation. Actually, it's the wrong word. I think it'd be a sigma expression. And it starts off like this: 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. you always want to find a pattern in these, and the pattern I see in this one is that this 4 is 2 squared, this 8 is 2 cubed, 16 is 2 to the 4. So I would rewrite this as 1 over 2 to the 1 plus 1 over 2 to the 2 plus 1 over 2 to the 3 plus 1 over 2 to the 4 plus 1 over 2 to the 5. That means we can get into our sigma notation. Sigma, the first number that needs to get plugged into this equation is 1. And then this 1 key changes to 2 to 3 to 4 up to 5. So it's going to end at 5. And it's 1 over 2. And it's 2 to that 2 to an exponent. And because you use the letter n here, you should use the letter n here. Frequently, people will use the letter k here. So if you use the letter k here, you need to use the letter k there. All right, I have 2 more examples. This is an example where it's not arithmetic or geometric, so you kind of got to common sense your way to an answer. The last 2 are arithmetic or geometric, at least I think they are. Example 4, let's say that I have 7 plus 9 plus 11 plus 13 plus yada 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 plus u18. Alright, I guess the first thing I need to do here is I need to make an assumption about where I'm starting here. I'm going to assume that this is u1. So that means that my equation that I need to come up with needs to be based off the fact that when I plug in 1, I get a coordinate of 7. So I'm going to use the point slope form. It's the same one that I used yesterday. And the slope, it's adding by 2, so the slope is 2. And then n minus 1 plus that first number, 7. That's the equation. And if I plug 1 into this, out pops 7. If I plug 2 into this, sorry, I got a little distracted. If I plug 2 into this, 2 minus 1 is 1. 1 times 2 is 2. Plus 7 is 9. If I plugged 3 into this, 3 minus 1 is 2. 2 times 2 is 4. 4 plus 7 is 11. So we're looking at sigma n equals 1, because that's the first, we first plugged 1 into this equation to get a value of 7. And we're going to go all the way up to 18 of, and then you put in your equation. And it should be in its own set of parentheses, and because my equation has parentheses, I'll put it into a bigger bracket thingy like that. Alright, that's number 4. I have one more example. If this one was arithmetic, I bet the last one will be geometric. 7 plus 14 plus 28 plus 56 plus yada 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 plus u9. Same thing, I'm going to assume that this is a u1 equation. And then because we are multiplying by 2 to get from number to number, that means it's a 2 to the n minus 1. And then we're multiplying it by that first number, 7. So just like we were doing in yesterday's. And then you put a sigma in front of it and parentheses around this, or a bracket like I did with this first problem. And because it started with u1, it would be n equals 1, and it goes all the way up to u9, so 9 up top. And that's sigma notation. When you're writing out your equations, it's always a good idea just to pop in some numbers and make sure it works out. For example, if this is u1, which would mean this 56 is u4, and if I plug 4 into here, 4 minus 3 is 4 minus 1 is 3. 2 to the third is 8. 8 times 7, boom, it's 56. It's checking out. Alright, I hope you're having a great day, everybody, no matter what day it is that you're watching this, and I'll talk to you soon. Bye-bye.